Hey there, it's Fashtus here. We're just going to do a quick introduction on behavior trees for those people that have heard about behavior trees being mentioned on the Discord, but are not quite sure what a behavior tree could do for them. And basically, a behavior tree is a method of providing artificial intelligence behaviors to something within the game. This little orc over here with the bow that's running around is currently running a behavior tree. And his behavior at that point was he was just running around patrolling. Now his behavior, because he's now seen me and I've hit me, he will attempt to keep within distance of me and shoot. And now his behavior, well, was running away, but then I killed him, unfortunately. So he has a flee behavior. So essentially behavior trees, the first part of them is giving various behaviors to an entity in a game, and the second part, tree, means that the whole behavior system falls in a tree. This differs from things like finite state machines and having a bunch of if statements in your game, where you may say, if I'm being attacked, and if I'm doing this, and if I'm not doing this, and if I'm running away. It makes it fairly complicated, and the coding gets very spaghetti-like, whereas a behavior tree, it's easy to add, move, put extra features in. I could add an extra leaf in here, which would give more functionality to the tree. So we're in a tree format. The tree has a variety of leaves. We start at the top, we branch out. Some leaves can have more than one leaf underneath them, other leaves can have one. And the behavior tree is run from the top, down, left to right. So the entry would be the first leaf, then it goes down to the next section, starts at the sequence, goes down to the next section. It's got two things underneath that, so it starts on the left, checks on server, checks the selector, goes down to the next one, and so on and so forth. It goes down all the way to the left, and all the way down to the left, and down, left, left to right, top to bottom, basically. The leaves, there's 4 different types of them. There's a composite, which is something like this one up here, which was the selector, which is the only leaf that can have multiple leaves underneath it. There is an action, like this attack target. It does something. There is a conditional leaf, like this look at target, or actually no, that's an action, like find another one somewhere. Find a flee location, for example. Here you go. So that it doesn't find a flee location, it will fail. And there's something called an inverter, which is a bit more complicated, but essentially it takes the output of a leaf and does something to it, changes it in some way. There's a variety of different types of them. Each leaf, the standard pattern for this sort of thing, will return one of various things. So the code will go into a leaf, the leaf will perform its code, and it will return something. And the return is generally a success, yes, the leaf worked. A failure, no, the leaf didn't work. Or a running, the leaf is still doing the thing. Now, running would be something like go to a certain location. So the leaf might report, I haven't gotten there yet, basically. I'm going to the location, I'm halfway there, I'm going to the location, I'm going to the location. So each time the system passes through all these leaves, it returns running for a while until it turns success. And by default, what you're looking for in things are successes, I guess. It's probably not quite true, because you can fiddle around with that. So you've got your tree and your code in the background. This is the base system that's running it, whichever you're using. This is Opsives Behavior Designer, but it works pretty much the same in any sort of behavior tree pattern. It starts at the top leaf, works its way through, and does this all the way through until it gets to the very end, or until it gets to the last leaf it can process, and ends. Now this is what trapped me up initially. It does this once, and you think, well, it's a bit worthless. I really wanted to do it more than once. I need to go and check back again when things have changed. And virtually all of these behavior tree systems usually allow you to say, look, keep on running this sequence forever, or run it over and over again. But there are situations where you may want to run a tree once. I'll talk about a demo or an example at the end. But just be aware that the design pattern says run through all of these items from top to bottom, left to right once, but it doesn't have to be that way. Generally, the systems in the back end will allow you to rerun it again as soon as it ends. Now, the composites, which were the prime, or one of the first leafs that I talked about, are the only leaf that can have multiple items below it, and they don't really check anything. They will essentially run all the leaves underneath them and return a success or fail depending on whether the leaves underneath them return a success or fail. Now, if you look at this one, this is a sequence. Opsives actually has a little bit of a tooltip at the bottom of this, but a sequence runs all the leaves underneath it, one after another, until it gets to the very end, or until the first one fails. The first one returns a failure. So if it runs the first one returns a success, it runs the second one returns a success, it runs the third one, fourth one, and it keeps on going until one of those sequences fail. There's other different types, such as, I've sort of renamed some of them. Probably the only other important one, so there's a sequence and a selector would be the two primary ones. Opsives has a couple of different ones. There's ones that randomize the order of the leaves underneath them, and there's others that have utility. So it's maybe have, say, 10 leaves underneath a composite, and they each decide how important they are at a certain point in time, and they will run those important ones first. It's a bit more complicated, but the basic ones would be sequence. It runs every single leaf underneath it one at a time until it finishes them all, or until one fails. And a selector runs each task underneath them and returns a success as soon as the first one succeeds. So if the first one succeeds, it won't run any of the rest of them. If the first fails, it runs the second. If the second fails, it runs the third. If the third succeeds, it exits out and returns a success. If none of them succeed, it returns a failure. So those are the only ones that can have multiple leaves under them, but they don't really do anything other than run the leaves underneath. The actual code would be something underneath it as an action. So there is various different types of actions. So I've written quite a few of them. So run to home would be an action, and that basically will take a vector location, for example, and it will make that character entity move to that location. This is an example of one that will return running. So the home distance check would come along, and everything's success. It hits that one returns running, and so it exits out and then comes back next time running, and until that returns success, it will keep on rerunning that one action over and over and over again. Actions could be things like attack something, move somewhere. There's one here that animates something, just animates a character. Send events. A log message is an action, so it could write out to the log. That's an example within the Behavior Designer. Conditionals are, so that action can only have one, and an action won't have a sub action below it. So an action can't have a leaf of its own, basically. Conditional is something which is expected not to do anything but to make a check. So can you see a different character on the map? Success, yes I can. Fail, no I can't. And that would be placed in I think there would be a conditional over here. Well, conditional, this is a conditional here, which basically just checks two variables. Is one variable the same as another variable? And that's all it does. If they are, it returns success. If they're not, it returns fail. And so that could be something like, if you're going to a location, or am I in a location? Is a character in a location? If that conditional, the current location and where you're trying to go to are not the same, well then that's a fail, and it moves on with life. And then the inverters are the fourth type, which are a bit more complicated and probably not something you need to worry about when you start out, but basically the inverters, the decorators, they're things like an inverter. That literally just takes the return value of the action or the conditional below it and inverts it to the other. So if it's a success, it's a fail. If it's a fail, it's a success. There's some of them, there's lots of different types of decorators, and they basically just do slightly different things. They could repeat an action over and over again, perhaps, or always return a failure, always return a success. They make more sense when you get a bit more involved in it. So essentially a tree sequences can perform actions and conditionals. And if you look at this, the most important actions are always on the left, or the most important behaviors are on the left, and the least important behaviors on the right. And if you look at this example tree, we'll make it a little bit simpler. If you can imagine this tree is running over and over and over again. We've got a quick check to see if we're on a server, but that's only MMORPG kit specific. But we hit our selector and we check, are we too far away from home? That's our most important overriding concern. If we get too far away from home, it means the player is kiting us somewhere and we turn around and we run home. But if we're not too far from home, that's a success. We move on to the next one. Well, next one's a morale check. Are we hurt? If we're hurt, is it below the threshold of our morale check? Have we run away? Are we running away? We're not hurt that badly, so this is a success, and we move on with life. So we get to the next one. Are we attacking? No, we're not attacking. We haven't got a target, so this will return again. Actually, I think this is a selector. So this will return failures. So this first one, home distance, we're not too far away from home, so it's a failure, so we move on to the next. Morale check, we haven't failed a morale, failure, move on to the next. We're not attacking someone, failure, we move on to the next. We're not being attacked by anything, failure, move on to the next. Can we see anybody around us? Failure, move on to the next. Patrolling would be the last thing, and nothing else is important, so we just basically wander around randomly, wait for a random time, and start off at the beginning. So some examples of things you can do with behavior trees. So you can see what we've got here. We've got a morale check. We're too far away from home. We're checking to see if we failed morale, if we're being attacked, who we're being attacked by. Now, somewhere in here we could add in between, say, the morale check and the attacking, because it's a little bit more important than attacking. We could add in a couple of trees in there that have a conditional that say, well, do I have a target? Is that target a player? Is that player's hit points below, say, 15%? So their hit points are below 15%. I'm winning the battle. So a little trick to do with AI, and which you can do here with behavior trees, is you can fake it so that now this monster has a worse hit rate. So it's actually whiffing a bit. It's not actually managing to hit the player. When the player is really, really injured, it loses the ability to hit the player quite as well. And so it can drag out that little bit of end battle. So that's it's a pretty easy little behavior that we can add into it. Just insert that in between morale check and attacking. We can add into attacking. We can get a little bit more complicated than what it is. We're just attacking the target at this point. But what we can say is if our hit points, as the monster hit points are above 50, then attack the target. If the monster's hit points are below 50, well then maybe we attack the target in a different way. We have a couple more special attacks that we only use, basically stages in boss monsters. We can also say somewhere around here, just before attacking, because it's slightly more important, below the morale check, again, if the monster is below a certain hit point threshold, and we haven't yet called for help, we can send an event that will call for help for allies with the same flags as us. In patrolling, or just before patrolling, we can add some extra trees in here that maybe look around in the area and see if there is something to do, a flower to pick, a tree to chop down. And if we see something, rather than just failing and going to the patrol, but we will then target that location, wander over to that location, play an animation of chopping a tree down, and keep on going. And so that would add a little bit more more feature to this sort of monster. It would look like it's wandering around a forest picking flowers. If there are no flowers in sight, then that fails and it skips onto the patrolling action instead, and then just wanders around randomly. And at some point in time, as it's wandering around randomly and it reruns the tree, it might discover some more flowers to pick and walk towards them, or it might see an enemy. So there's quite a few things to do with behavior trees to really expand your AI. Now I mentioned that by default, by the pattern of behavior trees, essentially the system is expected to go through every one of these trees one at a time, every one of these leaves one at a time, until it gets to the end, or until it gets, gets to the last cell or the last leaf, or until it fails everything. And it tends to only do it once. And as I said, most of these systems will allow you to rerun the same tree over and over again, but a system to do it once could be something like, if you imagine a smart missile being fired from a spaceship. As soon as it's fired, there is a behavior tree that the missile runs through. It makes a bunch of decisions. Can it see an enemy in the area? Of those enemies in the area, which is the one most hurt? Of the ones most hurt, which is the ones whose shields are down? Target that one, and then the last action of the tree is fly in that direction. So it's only something that needs to happen once. The missile doesn't makes up its mind when it's fired. It never really thinks about it again a second time. So this is a system where a smart missile would run a behavior tree in a single sort of run. Now something with behavior trees is, you can see this has got a very nice sort of GUI. You really want a behavior tree, if you're buying one or writing one, that has this visual interface. It's very hard to see what they're doing if you don't have a visual interface. I must say Behavior Designer is quite amazing, because I don't have to write any code. Once you've written your specific actions to target your specific requirements, I wrote these MMORPG kit, all of these actions I've written, send radio message and movements, all this stuff is unique because the monster entities in the kit are, they have their own movement mechanisms. The actual Behavior Designer comes with animation stuff it can do. I think it's got navmesh agents things, but these don't work too well if you're using it in the kit, because if you send a monster off on a path or set angular speed, that doesn't necessarily work on the server. It really needs to use the internal kit methods, which is why I've got our own. But once you've written these and written your own conditionals, you just sort of say, right, wander randomly, where am I, stick that in there, attach that to my selector, and wander randomly, and I'll attach that. I mean, this is going to do some really weird stuff. I mean, this will ask itself where I am and pass a success. So this whole system would basically get as far to this point as it can and then just fail, because it runs until the first success, and the first success doesn't really do anything useful. But it's pretty easy to drag these things in and create your own trees and your own extra sort of functionality. So it's a nice way of doing it. But any behavior tree system that you are going to use, I really recommend having a nice visual system for it. There is a free one, so I can't really work unless I run the game and compile it in, but the free one's got a basic tree in it. It's not as good. You can't design your trees through the tree, but at least you can actually see the tree while it's running. And when you, if we actually rerun this game, have a quick look at the tree. It's the last thing before I sign off. You can see while the tree is running in a decent GUI, you'll actually see everything light up. So failed, it failed, it failed, and that green flash that you saw was a pulse. So I think this is set to fire once every 0.2 seconds. By default it's set, the behavior tree is set to actually check each behavior tree every frame. It's not really required in this system, so I've set it for 0.2 seconds, and every 0.2 seconds it goes through boom 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 boom, one after another, until it finds one that succeeds, and then it exits out. So this green line and these red crosses are where they failed. You can see in this one it tried to attack, and we should see it pulse somewhere along the line. It has a target already, doesn't, and so it fails out of this one. So there's no target, so it doesn't actually do the rest of this stuff. There's a few more things in here you can see. After it's got a target, it also checks to see if the target's dead, and if the target's dead, well, it stops attacking them. But this is pretty vital, being able to see all this sort of stuff. It makes the debugging possible. That's about it. There's obviously a lot more complicated than that. There's a lot more to it than that. As I said, the composites in Behavior Designer, there's a lot more extra features. So where I said a selector basically runs every single leaf underneath it until one of them succeeds and then stops, passing success out, or if they all fail, it returns a failure. You've got things like a random selector where it randomly picks items within the tree. It doesn't start from left to right, it just randomly picks them as it goes through. So it might do number 3, 2, 7, 1, 9, 6 until it's done them all. Same with the sequence. There's priorities, there's parallels, parallel selectors. It actually runs them all at the same time. All the leaves in the tree get run at the same time, and as soon as one succeeds, the whole tree succeeds. It abandons the others. And there's a bit more complexity in Behavior Designer with something called abort types. That gets a bit more fancy, where you can say that this is an attack check, and this conditional is, do I have a target? Now, I could be meandering around randomly with a long wait because I'm sitting there, and you could be attacking the character and nothing would happen because it's still wandering around and waiting. This sort of abort type basically says, check this conditional constantly. If the conditional changes, abort everything that was lesser important, everything to the right, abort it all, whatever it was doing, I don't care, abort it and run this part of the tree. And so that's a pretty fancy thing to do with Behavior Designer. Anyway, I hope this helped a little bit. I can answer any questions anyone have got in the comments. And I'll get back to working on the MMORPG kit behavior design integration, which is almost finished. Have a good evening. Cheers.